In this video I'm going to go through a couple of examples of probability with and without replacement, and these are classic problems. So in the first example we have a bag of coloured balls. We have 2 red and 3 blue, and we're going to do 2 trials. So I'm going to take out 1 ball and then replace it, so this is with replacement. And then I'm going to take out a second ball and then replace it. So this first branch of the tree diagram, that's the first draw, and then this branch will be the second draw. Well, since there are two red balls and there are 5 in total, the probability of drawing a red ball on the first go is 2/5, and the probability of drawing a blue is therefore 3/5. Now, since we replace the red ball again, in the second draw there's still 5 in total. So the probability is going to be the same. It's going to be 2/5 on the second draw and 3/5 on the first. And if we go down this branch here, we've drawn a blue, so there's still 2 red, and then we replace the blue again, so it's still 3/5. So the probabilities do not change. And if I want to calculate the probability of choosing a red and then a red, PRR for example, I would multiply along the branches. So that would be 2/5 times 2/5. And then probability of doing a red blue would be 2/5 times 3/5. Probability of choosing a blue and then a red is going to be the same as red blue, be 3/5 times 2/5. But because multiplication has a property called commutation, these two are the same. Probability of getting a blue and a blue is going to be 3/5 times 3/5. And the sum of all these probabilities at the end of the branches should add up to 1 if you want to do a check, if you're unsure about your calculations. However, when we do not replace the balls, in the first branch the probabilities are still going to be the same because we have two red balls and 5 in total. Here we have 3 blue balls and then 5 in total. However, if I've drawn a red ball and I don't replace it, then there's only going to be in the second draw 1 red ball out of 4 in total. So the total changes to 4 in all branches. If I draw a red ball, then there's going to be 3 balls left. So the probability of, given that I've drawn a red ball, the probability of drawing a blue is 3/4. However, if I've drawn if I draw a blue ball on the first round, then I lower the total to 4 still, but I have 2 red balls left and 2 blue balls, so the probabilities change. And to get the probabilities, the combined probabilities, again I multiply along the branches. So probability red is going to be 2/5 times 1/4. This is going to be 2/5 times 3/4. This is going to be 3/5 times 2/4, which is a half, and this is going to be 3/5 times 2/4. So the important thing to note is without replacement, both the numbers of the individual balls change and the numbers of the totals change.